Hi guys, let us see recurrence relation. So what is a recurrence relation? A recurrence is an equation or inequality that describes a function in terms of its value on smaller inputs. For example, we take Fibonacci series, the nth term is represented by adding the n minus 1th term and the n minus 2nd term. That is, in Fibonacci series, a term is calculated by adding previous two terms. That is what we call it as a recurrence relation. So to solve the recurrence relation, a substitution method, here we guess an asymptotic upper or lower bound and then use mathematical induction to prove the guess is correct. That means we assume or we guess the relation, then we try to prove it using mathematical induction. Let us see an example for substitution method. So use substitution method to show that T of n is equal to 2 into T of n by 2 plus n is in the order of n into log of n. You see the relation T of n, a relation based on n, is represented in terms of relation based on n by 2. That is what we call it as a recurrence. That is, it is represented in terms of its smaller inputs. So here we assume the recurrence relation is in the order of n into log n. So we assume or guess the order of n into log n, and we want to prove that by mathematical induction. So here, so T of n less than or equal to C into n into log n. That is what we assumed. So here you substitute the 2 of T of n by 2 plus n, that is 2 into C of n by 2 plus log of n by 2 plus n. So how this comes, we are just substituting that this value 2 into T of n by 2 plus n, that is what you substitute here. So 2 into C into n by 2 plus log of n by 2 plus n. So now when you cross this 2 and this 2, that is, this 2 will be cleared. Okay, so that what will happen, T of n less than or equal to C into n into log of n by 2 plus n. Now we apply this formula, log of a by b is equal to log a minus log b. By substituting or by applying this formula, so this relation will become T of n is equal to C into n log n minus C into n log 2 plus n, because this log of n by 2 we have converted it as log n minus log 2 by having this formula. So now T of n is equal to C into n into log n minus Cn, because the log 2 value is 1. So when you multiply by 1, the same value will come. So that is Cn plus n. So now this can be written as T of n less than or equal to C into n log n, because whatever the value it comes here, when you subtract this, certainly this value will become less than or equal to C into n log n. This solution holds for the boundary condition, because when log 1 value is 0, so when log 1 value is 0 means the whole thing will become 0. So that is why we are saying that n value must be greater than or equal to 2. That is what we call it as a boundary condition. So T of n less than or equal to C into n log n for n greater than or equal to n0, where n0 is constant. In this case, the n must be greater than or equal to 2. So I can conclude that T of n is in the order of n into log n.